Today, our mission is to dive into a stack of recent tech reports. We're looking at everything from Cerebrus's new hardware specs to the WizRed team's security audits.
Yeah, there is a lot to cover today.
Right. So we really want to understand the hidden tension between AI's explosive growth and, well, its alarming security flaws. Because we've got models getting massively smarter, but we're also seeing the industry just sort of trip over its own feet.
Yeah, they really are.
Okay, let's unpack this. We have to start with the sheer scale of the hardware frenzy right now.
Oh, absolutely.
Like Cerebrus just unveiled their CS4 system, and they're claiming it delivers up to 30 times faster inference.
Right.
Which, is just the tech term for actually running the AI to get answered. So
Yeah.
30 times faster than current GPU setups.
Yeah, and 30 times faster for inference. That fundamentally changes what a model can process in real time.
Wow.
But building these machines requires physical manufacturing, and that capacity is totally maxed out right now.
Yeah, I imagine.
I mean, Samsung is actually hiking prices on their advanced foundry processes.
Yeah.
The massive factories that physically print these microscopic circuits.
Right.
They're hiking them by up to 15%.
Wow. It really highlights how physical reality is just constraining software right now.
Definitely.
Think of it like trying to pump an ocean of water through a garden hose.
Yeah, that's a good way to put it.
The bottleneck isn't the AI's potential, it's the physical hardware required to run it. So it's like a modern-day gold rush where the pickaxe sellers, like Samsung and Cerebrus, are basically calling all the shots.
Exactly. And if we connect this to the bigger picture, compute is the ultimate bottleneck right now.
Yeah?
That hardware scarcity explains exactly why we're seeing massive strategic investments to bypass it. Like Anthropic just signed a $250 million deal for specialized inference chips.
Oh, wow. With who?
With a UK startup called Fractile.
Okay.
Yeah. And that deal shot Fractile's valuation up to $6.5 billion overnight.
That is insane. And Google just secured a massive $12.2 billion warrant with Marvell to build custom chips, right?
Right, for storage and networking.
Yeah, they are just desperately locking down their supply chains to guarantee they have the engine power for the next generation of models.
And having that engine power is yielding some really wild results.
Yeah.
Because they have the hardware, capabilities are skyrocketing in fields you wouldn't really expect.
Like what?
Well, for instance, Anthropic's Claude model is now designing protein binders with a 22 to 35% success rate.
Okay.
The industry baseline in synthetic biology is usually around 10 to 15%.
Oh, wow. So it's way higher.
Yeah, it's literally doubling the standard for generating viable proteins.
Okay, but here's where it gets really interesting, though. I have to push back a little because there is a serious disconnect here.
Okay, what do you mean?
If AI is getting this incredibly smart at complex biology, why is it still writing such terrible code?
Right, well...
I was looking at the WizRed team report, and it talked about a GitHub Copilot autofix patch that actually created a shell injection hole in Snowflake's repo.
Yeah, that was bad.
And that vulnerability was exploited in just 5 days.
Right, well, it really comes down to the training data.
Okay.
Biology is governed by the strict, inflexible laws of physics and evolution. When the AI trains on molecular structures, it's learning absolute rules.
Right.
Code generation, on the other hand, is trained on millions of repositories from places like GitHub,
Right.
which is full of messy, flawed, vulnerable code written by tired humans.
So it's basically learning our bad habits.
Exactly.
Yeah.
And we are seeing the fallout. Going back to that WizRed team audit you mentioned,
Yeah.
the AI was supposed to automatically fix a bug, but instead it lazily pasted text directly into the code without checking if it contained malicious commands.
Right, which created that backdoor.
Exactly, a shell injection hole. And what's fascinating here is the dangerous feedback loop this creates.
Right, because 5 days from a patch to exploit is terrifyingly fast.
It is. AI isn't just making mistakes. It is actively accelerating exploit timelines for the bad guys.
Wow.
Security experts are warning that AI-assisted tools are drastically shrinking the window between when a bug is disclosed and when it gets weaponized.
Yeah, look at Apple recently scrambling to patch the image I/O zero-click flaw.
Right.
That's a hack that completely takes over a device without the user ever even clicking a malicious link. The margin for error for regular developers is basically disappearing.
It really is.
So what does this all mean? Well, expect the AI tools we use every day to get much more powerful, but potentially a lot more expensive.
Yes.
Because there's this hidden safety tax. Because these mistakes are happening so fast, OpenAI is now baking a massive 20% compute overhead strictly for safety monitoring.
Right, into Astra and their upcoming GPT 5.6 models. They are diverting a full fifth of their total processing power just to constantly double-check the model's output,
Yeah.
making sure it isn't generating malware or going off the rails.
Right. And while OpenAI might eat that cost today, their CFO just committed to a 2027 IPO.
Yeah, or potentially sooner.
Right. And when a company goes public, those massive overhead costs eventually get passed down to the consumer.
They always do.
It's a huge price to pay just to keep these powerful systems in check.
It is a massive price.
Yeah.
And it leaves us with an unsettling question to ponder as this arms race continues.
Yeah.
If frontier labs like OpenAI have to sacrifice 20% of their immense compute power just to monitor safety and keep the guardrails on,
Right.
how much compute will malicious actors actually need to bypass those exact safeguards?